Okay, so this is 6.6, and we're dealing with graphing sine, cosine, or not sine and cosine, tangent, cotangent, cosecant, and secant. So here are the answers to the first 20 problems or so and what they look like. So I'm just going to point through what they are, and then I'll do some problems at the end here. So remember the amplitude is here, and looking at 1 and 2, look at the difference of the amplitude. The periods are the same. Pi over 1 is your period, divided into two sections. That's pi over 2 for each section, minus pi over 2 and adding pi over 2. So this is your main point here for tangent at 0. And the amplitude is 4 here. The amplitude on number 2 is 1/4, which makes it flatter. So it's a vertical shrink of 1/4. All right, so that's those two. We look at 3 and 4, notice that our amplitude on number 3 is 1/3, and our amplitude on 4 is 3. So the 1/3 shrinks it vertically, so it makes it flatter, and the 3 makes it a little bit straighter, a little taller. Now the period for cotangent is pi, just like tangent, except the cotangent starts at 0. So I'm not really sure what was going on here. These should be shifted. Let me just redraw this. So the cotangent is at 0 and pi, and the middle is pi over 2. And the cotangent goes like this. So I'm not really sure what the original function of this was. These are not correct. They're not shifted over. So this is really what you're looking at. And then on this side, again, here at 0, it goes through at pi over 2 and pi, and goes like this. All right. So let's go to the next. Then we have cosecant, which we should know what the sine looks like. The sine curve with a magnitude of, or amplitude of 2 would look like that, but we don't need to write that because the cosecant, we know where the amplitude is. That tells us where our valley is and where our peak is. The problem is we need to know where these asymptotes are. And again, we're not shifting anything. So the sine goes from 0 to 2 pi, and we divide that into 4 equal segments. So each segment is pi over 2. We start at 0, go to pi over 2, add another pi over 2, another pi over 2, another pi over 2. And so where the sine function changes directions, that is, or excuse me, where it changes from a peak and a valley here, that's where your asymptotes go. All right. So if we look through, let me see if I can get this to work. Oh, well, it doesn't matter. Let's use a bigger pointer here. All right, number 6, notice the amplitude is 2, and here the amplitude is 1/2 for cosecant. So all it does is it gets it closer to the x-axis. All right, so you still have your sine function that's in there. It's just thinner than the one on the left here. Okay, secant goes with cosine, so if we draw the cosine in here, okay, so this is what your cosine would look like, except that's not what we're drawing. We're drawing the secant. And how do we know where the asymptotes are? Again, where the cosine crosses our middle part of our graph, which in this case is the x-axis, until we start shifting it up or down. Amplitude is 1/4, so it's very close to the x-axis. And here, on number 8, the amplitude is 4. So the secant's very high and very low. All right, number 9, back to tangent. Now we're shifting to the right by pi over 4. And what we should be shifting is your period is pi, and you divide it by 2, you still have a pi over 2 value here. All right, so we're going to shift to the right by pi over 4. And for some reason, I drew the cotangent on this one. So I'm going to erase this whole thing and do this part over. So we'll just do this. So we're shifting the typical tangent curve. Remember, tangent goes through at 0, goes like this. So this is your y-axis in the middle here. So we're going to shift this point pi over 4 to the right. So if we call this pi over 4, the next question is, where is your asymptotes? So we're going to subtract pi over 2 from the pi over 4. So pi over 4 minus the pi over 2. get a common denominator. So that's 1 minus 2, which would be negative pi over 4. So negative pi over 4 is where your asymptote is. And then pi over 4, we're going to add pi over 2 to the right. Yeah, get it on the right side. So again, multiply it by 2. So this is going to be 3 pi over 4. So there's 1, 2, 3 pi over 4 is where the other asymptote is at. And then we're going to draw our tangent curve amplitude of 1. Okay, now let's make sure we did number 10 right here. We are going to go shift to the left by pi over 2, and notice that's where we actually put our point. So our normal point is at the origin for tangent, and that's what we're shifting. We're shifting it pi over 2 to the left, and that's where we put the point. And from that point, we take our period and divide it by 2. We got to subtract pi over 2 from that. So a negative pi over 2 here minus pi over 2 gets me to the negative pi. And then another pi over 2 plus negative pi over 2 puts me at 0. So that's where our amplitude or our asymptotes are at. Okay, number 11 here. Again, we're not shifting anywhere, so the point still stays at the origin, but our period is pi over 2, the coefficient on x. And then we divide that by 2, which makes it pi over 4. So we're pi over 4 distance to the left and pi over 4 distance to the right of our center point. Okay, so that pretty much tells us where our asymptotes are at. Amplitude is 1, so we just draw it. Number 12, we have pi over the coefficient. Pi over 1/2 is pi times the reciprocal of this, and that's where we get 2 pi. Divide that by 2, and each of these distances are pi. And since we didn't shift left or right, then our origin is still where we're crossing the x-axis. So 1 pi to the left, we have our asymptote. 1 pi to the right, we have our asymptote. Okay, number 13. Again, we're not shifting left or right. So we still have our origin. That's where we're going through the x-axis. But our period is pi over the coefficient. Pi over 6 is pi times the reciprocal, 6 over pi. Cross those out. And so our period is 6. Divide it into 2 equal pieces. That means you have 3 on the left and 3 on the right. And that's where your asymptotes are. Amplitude is still 1, so it's not flat or tall. It's just right. So here we have our period is pi over 3. So pi times 3 over pi. So the pi's cancel, leaving just 3. So our whole length is 3 radians. But we got to divide that into 2 pieces. So each half is 1.5, or 3 halves. 3 halves is 1.5 on each side of our origin. Number 15. We're going to shift to the left. We got to divide off the 2 here. And pi over 2 divided by 2 is pi over 4. So we're shifting to the left by pi over 4. So our origin now has shifted to the left by pi over 4. Our amplitude is 2, so it's going to be longer and taller. And our period is pi over the coefficient, pi over 2. So our whole distance is pi over 2. So 0 to negative pi over 2, that distance is pi over 2. But we got to divide it into 2 equal pieces. So pi over 2 divided by 2 is pi over 4. So this is pi over 4, and this is pi over 4. And that's where your asymptotes are. Go to number 16. We divide out of 2. Pi over 4 divided by 2 is pi over 8. So that's where we have our pi over 8. Took our 2 out to the front here. 1/3 means we're going to have a flat curve. That's our amplitude. Now, period is 2 pi over this value, pi over that value. So pi over 2 is your period. Divide that by 2, you get pi over 4. So we shifted to the right by pi over 8. So it was at the origin. We go to pi over 8. That's our first point. That's where we're crossing the x-axis. And the left and right of that is going to be your pi over 4. So we got to take pi over 8 and subtract pi over 4. So that's 1 pi minus 2 pi is negative 1 pi over 8. So this is negative pi over 8 right here. So pi over 8 plus another pi over 4. So if we're adding pi over 8, or pi over 4 plus pi over 8, get a common denominator. So that'd be 1 pi plus 2 pi. That'd give me 3 pi over 8. That's where these are at. Number 17, reflection time. So a tangent normally goes from this direction up here. So we're going to flip that down, it looks like a cotangent. And it's 1/4, so it's going to be flat. This is actually probably a lot flatter than this. Divide by 1/2, and we take that out. So 1/2 is going to be here. So your period is pi over 1/2, or pi times 2, which is 2 pi. And if you take pi over 3 divided by 1/2, you're going to get 2 pi over 3. Okay, and so we're shifting to the left from the origin to negative 2 pi over 3. That's what this means. And then we got to go left and right half of the period. Since the period is 2 pi, because pi over 1/2 is 2 pi, divide that in 2. Each of these increments is pi, but now we got to figure out where they are. So you got to take negative 2 pi minus pi, get a common denominator, and that's where the negative 5 pi over 3 is. And then you also have to add pi to the negative 2 pi over 3, and that gives us pi over 3, just past the origin. And then you draw it. 18, again a reflection, so it's going to look, the reflection of tangent is going to look like the cotangent. But remember, the tangent is at the origin, and we're going to shift after you divide out the 1/3. That gives us shifting to the right by pi. So the origin crossing is now at pi. So what is this distance over here? We got to find the period. So the period is pi over our coefficient, and our coefficient is 1/3. So pi over 1/3 is going to be 3 pi. So this whole distance is 3 pi. So what is half of it? Well, half of 3 is 1/2. So 3 pi over 2. So we got to take pi and subtract the 3 pi over 2 distance, and that's where we got the negative pi over 2. And then we take pi and add 3 pi over 2 to get this value of 5 pi over 2. And then don't forget your reflection. You got to draw it down like that. 19 is cotangent, so this is your cotangent curve. So our asymptote starts at 0, so it's going to shift to the right by pi over 2. So that's where our asymptote is. We're not worried about the crossing. We only worry about the crossing with tangent. So our first point, or asymptote, is at pi over 2. Our period is pi over the coefficient, so pi over 1 is pi. So this whole distance has to be pi. Divide that into 2 pieces, that's pi over 2. So pi over 2 plus pi over 2 gets me to pi, and another pi over 2 gets me to 3 pi over 2. So now we're back to adding from the beginning point to each point. Cotangent again, amplitude's 1. And so pi over 1 is our period. Divide that, and we're going to shift left by pi over 4. All right. So that means our, and this is done wrong, I'm confusing all the tangents and cotangents. I'm glad I went back over this. Sorry about that. So our asymptote moves to the left by pi over 4. So our asymptote is right here at negative pi over 4. Okay, negative pi over 4. And from there, we got to add pi over 2 to each one. So negative pi over 4 plus pi over 2, get a common denominator. So that's going to be positive pi over 4. So that's where it's going through the x-axis. And then we take pi over 4 plus another pi over 2. Again, get a common denominator. And that's going to be 3 pi over 4. So 3 pi over 4. And that's our other asymptote. And it's cotangent, so we are going to draw it like this. And the period, or amplitude, is 1, so it's just a normal curve. Okay, 21. Cotangent again. We don't shift, so our asymptote's at 0. But our period is pi over 1/2. So that gives us 2 pi. And half of 2 pi is pi. So from 0, we add pi and another pi. And then we draw our cotangent curve. But our amplitude is 1, so it's a normal curve. Now we go to number 22. Amplitude is still 1. And we're not shifting, so our asymptote is at 0. And our period is pi over 2. And then we divide that into 2, that's pi over 4. So from 0, we go to pi over 4. Another pi over 4 gets us to pi over 2. Very thin. Now 23. Amplitude is 1. Again, we're not shifting, so our asymptote's at 0. And our period is pi over the coefficient of pi over 2. So pi times 2 over pi, the reciprocal. So we get just 2. So our period is 2 units long. Divide that into 2. Each one's 1 unit. That was pretty simple. Here we got pi over 4. So that's 4 units. So our period is 4 units long. Divide it into 2. That's every 2. So There's 2, and there's 2. And you draw your cotangent curve. 25, cotangent again, we divide the 2 out, and pi over 2 divided by 2 is pi over 4. So we got to shift cotangent. Our asymptote is now shifting to the left, pi over 4. So there's our asymptote, and from there, we got to find our period. So pi over 2, divide that into 2, that's pi over 4. So from negative pi over 4, if we add our distance of pi over 4, we get to 0. Another pi over 4 gets us here. And we draw it. Number 26, we have a reflection of cotangent, so it's going to look like tangent curve, but we're still drawing a cotangent. So our typical asymptote's at 0. It's got to shift to the right after you divide a 3 out. It's got to shift to the right by pi over 3. So this asymptote moved over to pi over 3, and then from pi over 3, we've got to figure out our period. So pi over 3 divided by 2 is pi over 6. So pi over 3 plus pi over 6, get a common denominator, gives us 3 pi over 6 or pi over 2. That's where we're crossing. And then 3 pi over 6 plus another pi over 6 distance gets us to 2 pi over 3. There's your asymptotes, and then you reflect the cotangent curve, and it's flat because your amplitude is 1/3. Number 27. We're reflecting cotangent again, so it's going to look like the tangent. And we factor out a 1/2, so that's going to be pi over 1/2 or 2 pi. So our distance is 2 pi. But we got to shift to the left pi over 8. So if you take pi over 4 divided by 1/2, because you factored out a 1/2, you'll get pi over 8. So we shift our cotangent original asymptote at the origin left to negative pi over 8. Then from negative pi over 8, we got to add half of our period. Half of 2 pi is pi. So that's where we get this information. Get a common denominator. So negative 1 plus 8 is 7 pi over 8. That's our next distance piece right here. And then we add another 7 pi over 8 plus pi. Get a common denominator. That's where we get 15 pi over 8. And then we draw a flat curve because our amplitude is 1/2. Now we get to 28. Now you get to see me do these. So our amplitude is 4, so it's going to be a tall curve, skinny. We factored out a 1/3. Pi over 6 divided by 1/3 is pi over 6 times 3, or pi over 2. So our cotangent has a period of pi over 2, and we're also shifting to the right by pi over 2. All right, so let me draw our typical cotangent curve here. Okay, so our typical asymptote is at the origin, but we're shifting to the right by pi over 2. So our asymptote, we'll say this is pi over 2 here. Okay, this is pi over 2. And then we have to take the period of pi over 2 and divide it by 2, which is really multiplying by 1/2. So each half is pi over 4 units long. So pi over 2 plus pi over 4, get a common denominator. That's going to be 3 pi over 4. Okay, so this is pi over 4, 2 pi over 4. So we need 3 pi over 4, which is going to be right there. That's 3 pi over 4. Okay, and that's 1 pi over 4 away from our pi over 2 asymptote. And then another pi over 4, which is going to be right here. That'll be pi. So our distance from pi over 2 to pi is still pi over 2. That's our period. Draw our dotted line for asymptote. It is cotangent. It's not reflected. And let's do it in black. It's fairly straight. There's a small curve to it. And that's your cotangent curve. All right, 29. Let's go ahead and see what we have. It's a secant, so that goes with cosine. So it's going to be the other values of the cosine curve. Our amplitude is 1, so a normal value in curve. So our period is 2 pi. Cosine has period 2 pi over coefficient of 1. So it's just 2 pi. Now we have to divide it into fourths. So 2 pi divided by 4 is pi over 2. All right, so we are shifting to the right by pi over 2. And typically, you would draw your cosine curve starting at 0, but we are going to draw it starting at pi over 2. So if we call this pi over 2, that's where it's going to start. Our amplitude is 1, so I'm going to put 1 here and -1 there. And that's pi over 2, the first mark. That's where we're starting. And every pi over 2 after that is your mark. So 1, 2, 3, 4. So that's going to be pi, 3 pi over 2, that'll be 2 pi, and 5 pi over 2. All right, so there's asymptotes for where the cosine crosses the middle of your x-axis. So what happens is the very center of your cosine curve, in this case, is going to be the 3 pi over 2. Each mark to the left and to the right of it is your asymptote. Now you can draw the cosine curve if you want, if that helps. But let's try to get to the point where we don't need to. So our secant curve is going to start where the cosine started, but it goes up to the asymptote. And it has a peak at the very middle, and then it comes down and stops at that point. And that's your secant curve. Now we got another secant curve on number 30, and our amplitude is 1, and our period is 2 pi over 1, or 2 pi divided by 2 again, or 4 gives us pi over 2 for all the increments. Now we're shifting to the right to 3 pi over 4 this time. All right, so let's draw our axes. We're shifting to the right, and let's do starting at 3 pi over 4. So if we do these increments the way we did the last problem, there's your 1 pi over 4. We should probably move the, so it's right here. All right, so there's 1 pi over 4, 2 pi over 4, 3 pi over 4. All right, so that's where we're starting. Again, our amplitude is 1. And we need 4 more places, but you got to add pi over 2 to each of these. So pi over 2, getting a common denominator of 4, makes this 2 pi over 4. So 3 pi over 4 plus your 2 pi over 4 gives us the next increment, which is 5 pi over 4. So remember, each 2 blocks is a pi over 4. So that's 4 pi over 4. There's 5 pi over 4. And then 6 pi over 4, 7 pi over 4. 8 pi over 4, 9 pi over 4. And one more, 10 pi over 4, 11 pi over 4. Okay, so again, your asymptotes go to the center point, and your asymptote is 1 to the left and 1 to the right. If you haven't figured that out yet, you can still draw your cosine curve and draw it from there. So here's where the cosine curve would start, but it's the secant, so it goes like this, and it has a peak at the 7/4, and then it comes down and stops at 11 pi over 4. So if you look at it, 11 pi over 4 minus the 3 pi over 4 gives us 8 pi over 4. 11 minus 3 is 8 pi over 4, which is 2 pi. That's our period. Number 31, you have amplitude of 1 here. So amplitude is 1. And your period is 2 pi over 2, or just pi. So we're shrinking half of the distance. All right, so let's draw. We are not shifting at all. So again, cosine starts at 0, secant starts at 0. And then we got to take our pi and divide it into 4 places. So it's every pi over 4 starting at 0 here. So our amplitude is 1. And starting at 0. And obviously cosine starts there. And we go every pi over 4. So I'm going to lengthen this a little bit more here. So we're going to say this is pi over 4. And this is pi over 2. We need 5 marks, or 4 after our beginning point. And this is 3 pi over 4. And that's pi, which is where we're supposed to stop. Our period is pi units. All right, now let's make our asymptotes. The beginning of, or the middle of your cosine curve is here. So 1 to the left and 1 to the right is our asymptotes. and then we draw our secant that has been scrunched down. Instead of going all the way out to 2 pi, which is what it usually does, it's been squished down to 0 to pi. Now, number 32, our amplitude, again, is 1, and our period is 2 pi over 1/2, which is 4 pi. We divide that into fourths. Every hash mark is a pi. All right, let's draw it. We're not shifting at all. So let's go ahead and get this going here. We're not shifting at all. So again, it starts at 0 and technically at 1 because cosine starts at 1. And what do we have here? Every increment, let's see, we'll just make that pi, 2 pi, 3 pi, and 4 pi. Obviously, it's a lot longer than what we're saying, okay? And again, the centerpiece is 2 pi, so we want 1 left and 1 right is your asymptote for cosine. And then we draw our cosine secant function. Okay, good stuff right there. All right, 33, again, secant, and we have pi over 3, so the amplitude is still 1. And the period is 2 pi over pi over 3, which is 2 pi times 3 over pi, which is 6. And we got to divide that into fourths. So if you divide that by 4, we get 3/2. All right, so each increment is 3/2. And we're not shifting again, so this makes it a lot easier to draw this. Starts at 0, and our amplitude is 1. So again, 1 and -1. And we're going to go by 3/2. So we'll just say this is 3/2. Another 3/2 gets us to 3. Another 3/2 gets us to 9/2. And 9/2 plus 3/2 is 12/2 or 6. And again, our asymptote, both of those for cosine, is 1 away from the center. And then we draw our secant curve. Okay, 34. Wow. So our amplitude is still 1. And our period is 2 pi over 2 pi over 3, which is 2 pi times 3 over 2 pi. Or 3 is our period. Divided by 4 is 3/4. Again, we're not shifting. So we're going to start at 0 again. I wonder why that first one didn't go on there right. Strange. All right. So every 3/4. So we'll just say 3/4 is the first one. Another 3/4 is 3/2 or 6/4. Another 3/4 is 9/4. And another 3/4 is 12/4 or 3. And we draw, I'm going to do blue for our asymptotes. It's easier to see. And then we're drawing, amplitude is 1 again. So from 1, we go up to the asymptote. We have our peak in the middle and then down at the end. 35. Now we have an amplitude of 2. So they're just going to be skinnier, but that doesn't appear to be anything. You're just starting at a higher value on your graph. All right, again, this is cosine. So the period is 2 pi over the coefficient of x, or pi, and we divide it into fourths, so every pi over 4. But we are shifting here. So let's rewrite this. Y equals 2 secant. If we divide out the 2, we get x minus, and that's pi over 2 divided by 2, which is going to be pi over 4. Okay, so now we can draw this. And it is shifting to the right. So how far to the right? It is shifting to the right by pi over 4. So we're going to start at pi over 4. And our amplitude is 2. And from pi over 4, we need to increase every pi over 4. So 2 pi over 4 is pi over 2. Then we got 3 pi over 4. And then we got 4 pi over 4, which is pi. And then we got to go another pi over 4, which is going to be 5 pi over 4. Okay, so our center is at 3 pi over 4, and our asymptotes are right here. And again, it's the cosine curve, starts up there, and it just has a bigger amplitude. Very simple. Okay, now 36. Let's divide out of 2. So we have y equals 1/2 secant of 2 times x minus pi over 2 divided by 2 is pi over 2 times 1/2, or pi over 4 again. So our amplitude is 1/2. So this is going to be very close to the x-axis. Our period is 2 pi over the 2 here, which is pi, and each one's going to be divided by 4. Each hash mark is pi over 4. So very similar to the last problem, except our amplitude is different. So let's draw this. We are shifting to the right, and by pi over 4. So we'll start at pi over 4 again, and we're going every pi over 4. So again, it's the same as the last problem, pi over 2, 3 pi over 4, you got pi, and 5 pi over 4. So the center is here, and our asymptotes are just to the right and left of it. Okay, and now we start at, we start at 1/2. So if that's 1 and -1, we're starting at 1/2, going up to the asymptote, and right there. There's your peak, and this goes down to there. So I'll just erase those little tiny ones. There we go. That's what it should look like. All right. So let's go on to the next few. We're almost done. We have a reflection of secant. All right. So it's the same thing. It's just going to draw it upside down. We need to divide out a 1/2. So y equals -1/3 secant of 1/2 x plus, and you have pi over 4 divided by 1/2 would be times 2, or pi over 2. So we're going to shift to the left by pi over 2. All right, so now let's get ready to draw this. To the left by pi over 2, so we'll say negative pi over 2 is right here. Going to the left. Our amplitude is 1/3, so this is going to be really small. So I'll just go ahead and put 1 here by 3s, right? So that your 1/3 is right there. So here's your -1/3. All right, and now from negative pi over 2, what's our period? Our period is 2 pi over 1/2, or 4 pi. So every increment will be pi units long. So pi over 2 plus pi, let's get a common denominator. So 2 pi over 2 we're going to add. That gives us pi over 2 again. So we're right here. Plus another 2 pi over 2 is 3 pi over 2. Plus another 2 pi over 2 is 5 pi over 2. And one more, plus another 2 pi over 2 is 7 pi over 2. Here's our center. So draw your asymptotes. And now we graph, but it's upside down. Remember, you got your reflection. So it starts at negative pi over 2. So right here, and it's going to go this direction. And then it'll have a valley at the top, and then come back down and stop there. 38, again, we have a reflection. Amplitude is 3. So that amplitude really on the last problem, it probably made it really flat for your curves. But that's all right. I'm not interested in that at the moment. Okay. Let's see here. our amplitude is 3, reflection, we got to move the 1/3 out in front, so y equals -3 secant of 1/3, x plus pi over 3 divided by 1/3 is pi over 3 times 3, so pi. We're going to shift to the left by pi. So again, getting a little bit further to the left. So we'll say each increment here, we'll say that that's pi over 2. So we'll say 2 big boxes is going to be pi. Okay, our period is 2 pi over 1/3 or 6 pi. Divide that into fourths and you get 6 over 4 or 3/2 pi. So if this whole distance here is pi, 3/2 pi puts us, that's 1/2 pi, 2/2 pi, 3/2 pi right there at pi over 2. So every 3 blocks. So we'll probably have to 1, 2, 3, 1, 2, 3. Yeah, we're going to have to move this over. So we'll just move everything over a little bit here. And we'll extend this line here. There we go. Okay, that's enough. All right, and another 3 blocks. 1, 2, 3, and one more. 1, 2, 3. So pi over 2 plus another 3 pi over 2 gives us 4 pi over 2. Plus another 3 pi over 2 is 7 pi over 2. Plus another 3 pi over 2 gets us to 10 pi over 2. Which that distance from 5 pi to negative pi is 6 pi units, which is our period. Now let's draw our asymptotes. And it's a reflection, don't forget, it's a reflection of the cosine or the secant. Our amplitude is 3. So 1, 2, 3, 1, 2, -3. So we're starting down here, going to the asymptote. And actually it's not much of a curve, so let's make it a little steeper. And this is going to be a little steeper. And this goes to there, probably a little steeper than that. So there's up to 38. All right, number 39. Cosecant. Now you're dealing with the sine curve and multiple asymptotes. So there's our amplitude is 1. Our period is 2 pi over 1. Divided by fourths, you get pi over 2. Okay? So we're not, we are shifting it. We're shifting it to the right by pi over 2. All right, let's draw our graph. Going to shift to the right by pi over 2. Okay, so we'll just call this pi over 2 right here. That's where the sine curve would start. And I'll talk about, I was going to say those are absolute values, but they're not. I put those in there. Those are values of 1. Okay, now we're going to go every pi over 2. So that makes this one pi, and 3 pi over 2, and 2 pi, and 5 pi over 2. Okay, so now let's put our asymptotes in. For a sine or secant, cosecant, it goes through the center and the outside. So if you're not sure, I'll draw your amplitude is 1. So here's your sine curve starting here. Okay, and I don't want you to draw it. So then our cosecant curve looks like this. So this the cosecant curve has 3 asymptotes, the center and the outside. So the secant curve only has 2. All right, let's move on to number 40. So we're going to move to the left by pi over 4. Our period is 2 pi again. And then we will divide that into fourths, so pi over 2. So nothing's really changed, but we're shifting to the left. All the way to the left, we're going to shift through to -3 pi over 4. So let's see. Let's do each big block is pi over 4. So there's -3 pi over 4. And then we got to go every pi over 2. So let's get a common denominator. That's 2 pi over 4. We're adding 2 pi over 4 to -3 pi over 4. That gives us -pi over 4. And so each increment is 2 hash marks. So 1, 2. What is that going to be? That's going to be pi over 4. Plus another 2 pi over 4 is going to be 3 pi over 4. And one more. That gives us 5 pi over 4. Okay, so put your asymptotes at the center and at the outside. And now we draw the cosecant without drawing the sine. Okay, our amplitude is 1. So let's see here, right there. And right here. There's your cosecant curve. Okay, cosecant again, and our period is going to be 2 pi over 1/2 or 4 pi, and each increment is pi. And we're not shifting, so that makes it really simple. Starting at 0, and we'll just say each one of these is pi. Pi, 2 pi, 3 pi, 4 pi. Starting at 0, and we got to put our asymptotes in. The beginning, the middle, and the end for cosecant. And our amplitude is 1. So there is the cosecant curve. 42. Period is 2 pi over 2, which is pi. So each increment is pi over 4. And we're not shifting again, so it starts at 0. Hello. All right, what the heck did this here? All right, sorry about that. Okay, hit the wrong button. And I gotta change this. All right, there we go. So start at 0, and it's every pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, and pi. Put your asymptotes in. And our amplitude is 1, -1. And now we put our cosecant curve in and move on. Cosecant again, their period is going to be 2 pi over pi, which is going to be 2. Divided by 4, each increment is 1/2. We're not shifting, so we can just go ahead and start at 0 again. Every increment will be 1/2, 1/2, 1, 3 halves, and 2. And you put in your asymptotes. And our amplitude 1 still. So there's our cosecant. And then we go to number 44. Our period is 2 pi over pi over 4, which is 2 pi times 4 over pi, which is 8. Divide that by 4, every increment is 2. And again, we're not shifting here, so this just makes it easy just to draw these. Not sure what happened with this right here. Let's just get rid of that. Okay, now it starts at 0, we're not shifting. So that's 2, 4, 6, 8, and that's it. All right, and draw your asymptotes. And then we draw amplitude 1 again. There's your cosecant curve. Cosecant again, but now our amplitude is 2. Then we're going to factor out a 2 here. So y equals 2 cosecant of 2x plus pi over 4. Our period is 2 pi over 2, or pi, and each increment is pi over 4, and we're going to shift to the left pi over 4. All right. So we'll just say our first increment here is negative pi over 4. Our amplitude is 2 and negative 2. And we got to go every pi over 4. So at 0, then pi over 4 again, 2 pi over 4, and then 3 pi over 4. So make your asymptotes for cosecant. And then go ahead and put your graph in. 46. Reflection. So that means, like on the last one, if it was reflected, this part would be down here, and this part would be up there. Okay, so just remember that as we get going here. So we're going to factor out a 2. We get y equals negative 1/2. And again, your asymptote, or your amplitude is 1/2, so it's very close to the x-axis. Cosecant of 2, and that's x minus pi over 2. So we're shifting to the right by pi over 2. Our period is 2 pi over 2, or pi, and each increment is pi over 4. Shifting to the right to pi over 2, so we'll just start this at pi over 2. Now let's go over 1. So let's put it here, and we'll say every big box is pi over 4. So that's going to be 3 pi over 4, 4 pi over 4, 5 pi over 4. We're going by, pi over 4. And then 6 pi over 4, which is 3 pi over 2. Put your asymptotes in. And remember, the cosecant is now reflected. Okay, so that means we're at 1/2. So 1/2 and negative 1/2. Okay, so right here is the reflected part, and here's the reflected part of the other one. Last ones. All right, reflection again, and we got to factor out a 1/2. So y equals negative 1/4 cosecant of 1/2, and that's x plus pi over 2 divided by 1/2 is going to be pi. So our period is 2 pi over 1/2, or 4 pi. So each increment is pi. We got to shift to the left by pi. This makes it much easier when they are all shifting and all the increments are the same. So we'll just say every box is pi. So this will be negative pi, 0, then pi, 2 pi, and 3 pi. And we put our asymptotes in for the cosecant. And then we get, let's see here, it's reflected, and our amplitude is 1/4. So I'm not going to draw it like that. We'll just say this is a 1/4 here, and this is negative 1/4. Okay, so this, reflection. So it's going to be down here for this cosecant, and then up here for the other part of it. Okay, number 48, we're not reflecting it, and the amplitude is 4. So all these curves on the left here with the 1/4 should have been really flat, and these will be skinny on number 48. So we're factoring out 1/2, y equals 4 cosecant of 1/2, and that's x minus, so pi over 4 divided by 1/2 is pi over 4 times 2, or pi over 2. So we're shifting to the right by pi over 2. Okay, so we'll just call that pi over 2, and we're gonna, our period is 2 pi over 1/2, which is going to be 4 pi, and each increment is pi. So we're starting at pi over 2, we add pi, that gives us 3 pi over 2, plus another 2 pi over 2, which is 5 pi over 2, plus another 2 pi over 2, which is 7 pi over 2, and one more down there is at 9 pi over 2. Okay, put our asymptotes in for cosecant. And then we draw it, it's right side up. If our amplitude is at 4, so we're just going to say this is 4, and that's -4. So it's very tall. So there you go. And that's what it is. But remember, these are the distances here away from the x-axis. That's it. Good job.